We're going to write some code now. Our objective is to create a searchable database of all daily stock price movements. We'll do this for the National Stock Exchange of India, which will have all Indian stocks. At the end of this exercise, you can input a stock ticker as the user, and our code will output an Excel sheet with a graph of the stock movement for an entire year for that particular ticker. We'll continue to build on the example that we used for our file manipulation, where we downloaded and parsed a zip file of stock movements in one day from the National Stock Exchange. Step 1 is to create a table with the columns and the schema that we care about. So at this point, this table will be blank. There will not be any data in it. We'll download the stock movements for an entire year from the National Stock Exchange website and then insert rows into this table. So step 2 is to download and unzip daily stock movements for a year from the National Stock Exchange of India. You can do this so that you have a long enough history. Imagine that you are an independent trader. Imagine how useful it will be to have all these stock movements available to query at any time. So download and unzip all the daily stock movement files one time for both this year and last year. Then you can query it at any time. So let's get into step 1. As we already said, step 1 is to create a table with the schema that we care about. This table is going to hold all the stock data that we download from the National Stock Exchange of India. We'll import some standard modules that we can use to download and unzip the data as well. urllib2 QuicklyLib zip file OS you have seen before. SQLite 3 is the library that we are importing to connect to a database. Time and date time will be helpful when we try to format the time from the files that we parse. We'll open a connection to the database. Con is the connection to the SQLite 3 database, example DB. Then we'll set up a cursor. This cursor is like a session on this database, and through this cursor we can run SQL commands on our connection. So c.execute followed by the query that we want to run or the SQL command that we want to run on the database is the way to do this. This is how you will interface from your Python code to the database. Notice how we are creating a table prices with all the columns that we care about. Symbol, which is the ticker, series, which mentions whether it's an equity stock or some other type of stock, the open price, high, low, close for a given day, the last day's price, total traded quantity in a day, total traded value in a day, and the actual date. We also have a few other columns. Now, as you know, create table also specifies the primary key of the table, which here we have specified to be the ticker, the series, and the timestamp. So for each ticker belonging to a series, on a given day, there is only one row in the table. All of these columns have been specified along with their data type or column type, like text or real to specify decimal numbers, and so on. Creating a table is a write operation to the database, so we have to commit before we move on. Otherwise, the changes would not be saved or they will not reflect the next time you open a connection on this database. Step 2 is to download a bunch of files and unzip them. We'll download them from the National Stock Exchange of India and then unzip these files. We've done this before when we worked on our files example. We'll just put our code in a little more modular, reusable fashion. So we'll set it up as functions. But the code basically was already written in the files example. So you can just copy that code over, but make sure it is indented and inside the body of this function. So let's go and fetch the code from the other project source code. Okay, we've pasted the code here, but the problem with doing this is that the indentation gets all messed up. Also, you have to make sure that the indentation is such that all the code is one step indented inside the function. So now we have a function that, given a URL, will download it from the National Stock Exchange of India and store it in the local zip file path. Next, we'll put up another function which will unzip the file which is located in the local zip file path and extract its contents to the local extract file path. Again, we'd written this code earlier, but it had not been modularized or put inside a function. So let's fetch the code from the other project and indent it so that it is inside this particular function. Make sure you fix all the indentation so that the entire bit of code that unzips and extracts the file is indented. So now we have two functions, one to download one URL from the National Stock Exchange of India and the other to unzip the zip file that's downloaded and then extract its contents. Let's set up one other function that's going to use these two functions. It builds on top of these two functions, and given a list of months and list of years, it will fetch all the data, that is all the zip files for all these lists of months and years from the National Stock Exchange of India. So it will call this function once for each day in each month in each year of this list of months and list of years. The way to do that obviously is to use a for loop. So for year in list of years, we have an indentation change, so we are inside this for loop. Inside that, for each month in the list of months, the indentation changes yet again, so we are inside the second for loop. Then we have the third for loop for the days in the month. Now there are basically at the max 31 days in a month, so we can use range of 31 to create a list. This is a list of numbers from 0 to 30. Since this list has numbers from 0 to 30, but we actually want the numbers to go from 1 to 31, we'll say the date is actually equal to day of month plus 1. The code that follows basically constructs a URL based on the pattern of the URL for one particular day. So if you remember, this was the URL to download a zip file from the National Stock Exchange for one day. We'll examine this URL and look at the pattern for different dates and months and years and figure out a way to construct the URL for a given month, day and year. So it looks pretty simple. It's the year followed by the month with 3 letters representing the month, and the file name has CM followed by the date followed by the month followed by 2015. So since we need a string to represent the date, for example 07 represents the date here, we'll convert the date to a string. Then we'll add a 0 to the date in case the date is less than 10. So if date is less than 10, we'll convert the date string to 0 plus the original date. Notice how the indentation changed to make sure that we are inside the if statement for appending the 0 to the date. Once you are done with that, change the indentation back. Then print the date, month and year strings to the screen so that the user knows and can keep track of where you are in the download process. Next, we'll construct the file name. So file name is CM plus the date plus the month plus the year plus the string bhav.csv.zip. So this particular pattern recreates the file name of the zip file that we'll download from the URL. Along with this, we can construct the entire URL, which will obviously be nseindia.com/content/historical remains the same, /equities as well. Then we'll have the year followed by slash followed by month followed by slash and the file name which we just constructed. So this is the URL of the zip file. Let's also construct the local disk path where this downloaded file will reside. So this will be a path on your local disk plus the file name which you just constructed. Now that you've constructed the URL to be downloaded and the file path where this particular file will be stored, we can call the download function. The download function will take in the local zip file path where the file which is downloaded should be stored and the URL which needs to be downloaded. Once this function is done, we need to make a call to the unzip function, which will take in the file which is now stored in the local zip file path and extract its contents to the local extract file path. So at the end of this, for each day, month and year, a zip file would have been downloaded and the corresponding CSV file would have been extracted and stored in this path that we are specifying. So we're going to do this for say a year or two and for all the days in those years, so maybe about 365 or 700 times. This might actually inadvertently overwhelm the NSE website. So we'll take a pause of 10 seconds to make sure that we are not overloading it. Time.sleep then will pause for 10 seconds before it executes the next bit of code. So now we're done with all three loops. We'll get out of all three for loops. So we have gotten out of the for loops and we are printing. We are done with downloading and extracting. Right. This was all in a function, if you remember. So we need to make a call to the function. We'll initialize a variable with a local directory, which is the extract file path where all these files will be extracted. This is going to be a lot of files and you might need to make sure that you have enough disk space to store all these files, which will be in a few tens of MBs. So after you're done initializing a path or a directory where all your downloaded and extracted files will sit, you also need to initialize variables which for the list of months and list of years through which we'll iterate. Now as you remember, the list of months has a pattern. It's the first three letters of a month in caps. So make sure that your months are in that pattern. So once you're done with that, initialize another variable with the list of years. So this could be 2014 and 2015. I've only shown you 2014 here because I've already downloaded the files before for the year of 2015. But if you're doing it for the first time, initialize your list to be for both the years 2014 and 2015. It will take some time for the program to go ahead and download all of these files, especially since we are asking it to wait 10 seconds between each call to the NSE website. So go have a cup of coffee, come back, and you'll have all your data downloaded from the National Stock Exchange website. Cool, our code ran successfully and it's downloading all the files from the NSE now, as well as extracting them and putting them in the path that we specified. So once you're done with this, we'll move on to step 3 and 4 of our algorithm, which will be in the next class.